have already done a course on proportionality intercept theorem. I have not talked about the converse of the proportionality intercept theorem with you, but I wanted to be able to mention that to you today so that when we do start doing revision for our June exams, I've covered both of these with you. So that's really the focus today. It's just the revision of the proportionality intercept theorem. And then our focus, I'm hoping, will be on the converse. Okay, so just to run through the converse of the, the proportionality intercept theorem with you guys. Again, very simple example. All right, we are given a triangle and we are told that there is a line that is parallel to the third side of the triangle. So in this case, we are told that DE is parallel to BC. Now, if there is a line like DE and it is drawn parallel to the third side of the triangle, what proportionality intercept theorem tells us is that it cuts the remaining two sides into the same proportions. All right, so in other words, AD over DB is the same as AE over EC. We know that that statement is called a proportion and that it can be manipulated in order to find the length of a particular piece of a side. All right, so that's what we're going to do in this case. They tell us here that AB, so this whole side over here, is 28 millimeters. And on the other side, they say that side AE is 4 and EC is 3. Okay, so now those are not lengths. That is a ratio. Okay, 4 is to 3. And ratios are obviously different to actual lengths, but ratios can come from lengths. All right, so now, if we want to calculate the length of BD, the easiest thing for us to do is to put BD into the numerator. So what I would write is that BD over, now I don't have AD. So I can't have two unknowns in an equation, otherwise I can't solve it. So I'm going to use AB. So what I do on this side of my proportion, I've got to do the same thing on the other side. So on this side over here, the side that would not correspond, but I suppose go with BD would be EC, the little one, over the whole thing would be AC, like so. All right, so that statement there is called a proportion. And when I make a statement like that, I have to write my reason proportionality intercept theorem next to it. And then I must not forget to name the parallel lines. So DE parallel to BC. All right, in tests and exams, they can give you a mark for the statement and a mark for the reason. If these parallel lines are missing, you're not going to get this reason mark over here. So very important when working with the proportionality intercept theorem, you must remember to name the parallel lines. Now it's easy. I can go and substitute in. BD is what I am looking for, and it means everything else needs to be known. So that would be 28. EC is 3, and AC would be obtained by adding the proportions of AE and EC together. So 4 plus 3, that would give me 7, like so. Okay, and then I can cross multiply and solve for BD accordingly. All right, so BD is going to be 7 times 28. Sorry, I'm talking nonsense. 3 times 28. 1 second, sorry. So 3 times 28 over 7. And we don't need a calculator here because we know that 28 divided by 7 is 4. And 3 times 4 is 12. You're not going to get any extra marks for writing millimeters, but I'm just doing that and adding it in. Okay. All right. And then obviously there would be a mark for our answer like so. All right. Does this ring a bell? Does it sound familiar to you? Do you remember us doing this earlier last term? Is it coming back? Yes. Oh, good. All right. Lovely. Okay. So now you guys are going to try one and then we're going to move on to something a little bit more difficult. Okay. Screenshots. So I'm just saying last time, screenshots, everybody, before we move on. Okay. And there we go. All right. So I would like you guys to try this one, please.
We're doing so well. Let's do this, my people. That's you. Uh-oh. Oh, no. Sorry. I was so happy to tell you that my electricity was back, but then they just cut us again. Then I don't...
No. How irritating. I know load shedding is a real pain in the bum, isn't it?
Michali, no worries. We have everything recorded for you. And you definitely learn something today. You'll get it fast. I don't even know what's going on.
Okay, so a few people with answers already. That's really nice. Well done. I'll just wait another minute or so and then we're going to move on. If you haven't done this course before and you are new to Watobe, then all the recordings of previous lessons are available. If you go and watch them, then it's going to help. Remember, this is not a very long course. This is just a refresher to help you with what you're going to be doing at school this week. We're doing this so that we can align ourselves with the ATPs, and then we will start analytical geometry next week. Okay, so I see a lot of people saying that M is equal to 4. Anybody want to tell us how they set that out? Anybody want to share their answer and tell me how they did it? You're welcome. Oh, there's a whole bunch of people that hands. Okay, Zwanaka, go for it, Zwanaka.
Good day, ma'am.
Good day.
Ma'am, for my answer, I did M over 2 equals M plus 2 over 3, reason, proportional, prop, intercept, JH parallel to EF. I did
Very
2M.
nice.
That cross multiply 2M plus 4 equals 3M. 2M plus 4 equals 3M. So I got an answer of M equals 4.
Yeah, lovely. Well done. That's beautiful. I couldn't have done it better than that. Okay, very nice. You just went straight to that. Perfect. Absolutely. Okay, so what Swanaka did here was perfect. You don't have to write dg over ge equals dh over hf first. You are allowed to substitute in. There's absolutely nothing wrong with that. So reason, statement, reason, and then answer. Very good. Okay, so please take a screenshot if you need to. I'm going to move on to the next thing because that was meant to be easy and I'm glad that it was. Okay, any questions quickly before we move on? Or are we all good? All right. Okay. Here is another example for you guys to try. It is well, I'm going to do this as an example with you, and then you guys are going to try this one for homework. This is going to be a little bit more difficult. The truth of the situation is that we're not going to always work in just one triangle, right? So most of the time, sorry, please can we mute? Please can we mute? Thank you. Please mute everybody. Thank you. The truth of the situation is that we are going to be working in more than one triangle when we do end up doing this in exam questions. Even these ones here are a little bit simplistic, but we will do the exam questions in June just before you end up writing exams. I'm not going to worry about doing the exam questions now. Let's put the information onto the diagram and then we can take it from there. So they tell us that T and U are points on RS and W is a point on QS such that QT is parallel to WU. All right, so now they're telling us this for a reason. So QT is parallel to WU and QR is parallel to WT. Okay, the reason that they tell us that is because they are trying to give us a clue as to which triangles we need to work in. So can anybody tell me which triangles are we working in this situation? There are two triangles in which you can apply proportionality intercept theorem. What are they called? Can anyone tell me? There are two triangles in which you can work here, guys. What are they called? So Lorato says SQ, oh, that's Chloe, sorry. So Lorato is saying QST, that's correct, Lorato. This one over here, QST is correct. All right, and QRT, you cannot work in QRT because there is no line parallel to the third side. SQR, yes, that is correct, SQR. All right, so let's get a slightly darker color. There we go. All right, so this triangle over here. All right, so the only two triangles in which we can apply proportionality intercept theorem is going to be the blue triangle because WU is parallel to the third side QT, and triangle SQR because WT is parallel to the third side of that triangle, which is QR. Let's go and put in the lengths of the sides that they have given us. So they've told us that QW is 12, WS is 11, TU is 6, and they want us to calculate the length of RS. What we can see is that when we want to work out RS is made up of SU plus UT plus TR. It's those three pieces added together. We already know what UT is. We know that it's equal to 6. So that means we need to calculate SU and TR. That's our focus. So now calculating SU first of all. Can anyone make me a proportion to calculate SU? Can anyone make me a proportion to calculate SU? Nolitando, go for it.
Hi, ma'am.
Hi, Nolitando.
Ma'am, using the triangle QST, the one in blue, you're going to say SU over UT is equals to SW over WQ.
Beautiful. Keep going.
And then SU is the one that we're finding, and then over 6 is equals to 11 over 12. And then we're gonna cross multiply, which is going to be 12 SU is equals to 66. And then 66 divided by 12 is 5,5.
Lovely. Okay, now, Nolitando, you've forgotten one tiny little thing. Do you know what that is?
Yes, ma'am.
Yes.
Stating the proportionality intercept theorem and the parallel lines, which is W is parallel to QT.
That's it. Beautiful. All right. I could not have said that better. Beautiful. Well done. Very nice. Okay, so we're getting a piece of the puzzle now. We know that this is equal to 5,5. Now we need to work out the length of TR. Okay. There's more than one way that we can do this. The most traditional way would obviously be working with ST and TR, but because we know the length of the whole side of SU Q, we could also work with the whole length of the side in this situation as well. Okay, so there would be more than one way for us to be able to do this. Anybody want to? Yes, they said a whole number, correct. So that's RS. So we're going to keep our decimal places until the end. Okay, that's only SU that we found. Okay, you're going to see what we do at the end. Okay, we will end up with a whole number, I promise. Okay, anybody want to help me with TR? How would I work out what TR is? Anybody know what to do with TR? Nolutando, okay, go for it. Cool.
Hi, ma'am.
Hi.
So now we're going to be using the big triangle, the one in red.
Mm-hmm.
And then
Good.
so it is going to be TR
Okay.
over the 55 plus 6, 5,5
Plus
plus
6, yes.
6, which is 11,5.
Good.
And then we're going to say that 12 over 11.
Lovely. Well done.
And then
Okay.
we're gonna cross multiply to, and then the proportionality intercept theorem, which is
That's it.
WT is parallel to QR.
Good. Well done. And again, you're going to end up cross multiplying, aren't you? Keep going. You were doing so nicely.
11 TR is equals to 11,5 times 12, which is 138.
It is. So 11 TR is going to be equal to 138. And what I want you to do here is round TR off to one decimal place. What do you get?
12,5.
Lovely. There we go. Okay. And now we can finish this question off by saying, okay, we've got all the bits and pieces we need for RS. RS is the sum of SU, UT, and TR. So that's 5,5, 6, and 12,5, which means that it would be equal to 24. Okay, Matrix, are there any questions? Don't forget to take screenshots. Onatile, welcome to unmute and speak.
Hi, ma'am.
Hi, Onatile.
Ma'am, I just wanted to ask, ma'am, why did you choose those triangles specifically?
Okay, because you've got to find a triangle where there is a line that is parallel to the third side of the triangle, because it's only under those conditions that you can apply the proportionality intercept theorem.
Oh,
Okay, so
Thank
you
ma'am.
can't, so for example, you can't work in triangle QTR because there's no line parallel to the third side of the triangle. Okay, so that's what you're looking for. All right, is a line parallel to the third side of the triangle. And then when you've got that, you can make your triangle and then you know which triangles to work in. Okay.
Thank you, ma'am.
Oh, pleasure, Onatile, no problem. Okay, now this bad boy here is your homework this evening. Okay. It's not a particularly difficult question, but I want you to try this. And what I'll do is I'll put up the answers for it next time. And the reason that I'm going to give this to you as your homework is because I want to focus on the converse of the proportionality intercept theorem. So please take a screenshot of that. Before you answer this question at home, please redraw the triangle for yourselves, okay, and put in all the information first and then start the question. It's very difficult to try and work on geometry questions off your phone. You've got to be able to write on the page. Oh, Ria, I don't know what we can do.
Ma'am,
Yes.
she can rewatch the recording because I know the homework is gonna be visible in the recording.
Yes,
and then
that's right.
screenshot it or maybe pause it. I don't know if she'll have data though.
Yeah, that's actually a really good suggestion. Okay, so Ria, maybe what you're going to have to do is re-watch this and then just pause when you get here. Okay. We've got to think of a way around screenshots. Okay. All right, I'm going to move down to the next bit. If you need to take a screenshot of this again later or whatever, then I can go back. Okay, so the real reason that we are doing this particular lesson is because I didn't get a chance to talk to you guys about the converse of the proportionality intercept theorem in our last course. And I wanted to go back and touch on it again so that when it comes to us doing exam preparation, I've covered all these concepts with you. It's actually very easy, and it's something in my experience of teaching matrics over the last few years that they often seem to miss out the marks on this for some reason. And you don't need to, because it's not actually a difficult thing to prove. What it requires, however, is a good understanding of the fundamental basics. All right, remember, converse proportionality or proportionality intercept theorem tells us, all right, if in a triangle there is a line parallel to the third side of the triangle, it cuts the remaining two sides into the same proportions. That's what we were doing in this question. It's because GH was parallel to EF that it allowed us to write M over 2 equals M plus 2 over 3. All right. When we are doing a converse, we are working backwards. So in other words here, what we've got are the lengths of the sides. What they're asking us to prove is that DE is parallel to BC. If that's what they're asking us to prove, it means we cannot write AD over DB equals AE over EC. That's what we're trying to prove. So that can't be our first statement. That is what we are trying to deduce. So when you are proving a converse of something, all right, the idea is that let's say a murder gets committed, right? And let's say for whatever terrible reason, they say Lee is guilty of this murder. They can't say Lee is guilty because she's guilty. I have to be guilty because the victim's blood is on my hands, or I have the murder weapon in my car, or somebody saw me shoot the person. Do you understand what I'm trying to get at? I'm not guilty because I'm guilty. I'm guilty because of other things. All right. And it's the same thing in maths. It's not true because it's true. It's true because of a calculation that we have done. All right. So we cannot start out assuming that AD over DB is equal to AE over EC. That's what we're trying to prove, because that is what proves DE parallel to BC. So it's very simple. How we set it out is like this. We work out what AD over DB is equal to. And in this case, it's equal to 10 over 3. We also, in a separate calculation, work out what AE over EC is equal to. In this case, it's 15 over 4.5. Now, you would do that on your calculator. If you put 15 over 4,5 on your calculator, you will see that it is also equal to 10 over 3. So there we go. The sides are in the same proportion, which is 10 over 3. So now we can conclude what it is we're trying to prove. At AD over DB is equal to AE over EC. Therefore, DE is parallel to BC, and our reason for this, converse proportionality intercept theorem. Okay. All right. So I'm going to grab that and stick it over here just in case anybody wants to do a screenshot. That's how we would work with it. Okay. Please remember to mute, guys.
Ma'am, can you please explain again?
Okay. What do you not understand?
Ma'am, I think everything.
Okay. When you say everything, what I've done is I've just worked out the proportion of AD is to dB and the proportion of AE is to EC, it's equal to the same thing. So I'm just writing that those two proportions are equal to one another. And then I'm concluding, therefore, the lines have to be parallel. And the reason for that is converse proportionality intercept theorem. Let's try another one. Okay, we're working backwards. Exactly, Shoshana. You're just working backwards. Okay, it actually is very easy. It's meant to be easy. It's not meant to be particularly difficult. Okay, let's try another one. Okay, here you go. So we're going to use the information on the diagram and you're going to try and prove that AB is parallel to EF. It's identical to the previous question. You just make it a little bit bigger. I'm going to give you guys a chance to try this one. Katleho, just give it a try. It doesn't matter if you don't get it right straight away. Okay, what you can't do is you cannot start off by saying dA over AE equals dB over BF, because we do not know that AB is parallel to EF. So we may not write that. There we go. Yes, exactly. Exactly. Perfect, guys. 100%. Okay, so as long as we set it out in the correct way, that's it. Good. Well done. All right. So hopefully you guys wrote dA over AE equals 7 over 3. And you wrote dB over BF equals 21 over 9, which also equals 7 over 3. And then you would conclude that that means that dA over AE equals dB over BF. And then therefore we've proved that AB is parallel to EF, converse proportionality intercept theorem. Okay. No, Zoom user, it doesn't matter. If you want to go AE over DA is equal to BF over DB, you can do that. Ludwina, I see you. I'll take your question right now, I promise. Zoom user, the other thing that you can do if you want to is you can also work with a whole length. So you could work with dA over DE equals dB over DF. All right, so there's a number of different ways in which we could do that. This is the most common way of doing it. Ludwina, what's your question?
Hi, ma'am. How are you?
I am fine. How are you?
I'm good, thanks, ma'am. It's not really a question that's related to the question that we just did. I just wanted to ask, I'm not sure if I'm overstepping in any way, but I'd like to just like comment how it's kind of discouraging when I'm like still trying to work something out and then people are already commenting the answer. So I wanted to ask if you could maybe like give us a time frame where we work it out and then you ask for the answers before people just comment their own answers.
Sure, absolutely. I'm happy to try that if you'd like to try that. Not a problem at all.
Thank you, ma'am.
Okay, no problem. No problem. Okay, and Koki agrees with you. All right, absolutely no problem. I don't want anybody to feel discouraged. Okay, so we'll keep our answers back, and then when I give you a time frame, then we will call for answers then. Okay, she does. I agree. She does. Perfect. Let's do it like that from now onwards. Cool beans. All right, are there any questions about how to prove lines are parallel using converse proportionality intercept theorem? Are we all good? Are we happy to move on? Okay, Ludwina, I see your hand is still up. I'm assuming that might be from earlier. Okay, all right, on to the next thing. Okay, so here is a question for you guys to try, based on what we have spoken about this evening. So Koki, what I've done is I've used converse proportionality intercept theorem to prove that lines are parallel. Okay, so now you're going to try the same thing in this particular question. What I'm going to do is I'm just going to assist you a little bit, and I'm going to put in the information that is given onto this diagram for you. Okay, so they've told us that BG is parallel to CF. That's already been shown to you by the fact that there are arrows on the lines. The other thing that they tell us is that AF equals FE. So I'm going to put two little lines at AF and two little lines at FE for you. AB is 2 centimeters. That's going to be 2 over here. BC is 3 centimeters. CD is 1 centimeter. And DE is 4 centimeters. All right, I would like you guys to try question A and B and C, please. All right, and then remember, we're not going to share any answers until we are asked to. I am going to give you, let's say 6 minutes. You may be able to do it faster than that, but let's see what happens. Of course, if you've got any questions, you can either ask myself or Eric has stepped back in to assist. He also may be able to help you. Okay, so the colon means they're talking about the ratio. Okay, so AG is to GF. What is the ratio of AG is to GF? So for example, if something is twice more than something else, we could say the ratio is 2:1. Like let's say I have 1 sweetie and you have 2 sweeties, then the ratio of our sweeties is 2:1 or 1:2, depending on who we decided went first. I'm not going to say anything about the answers just yet, Ria. We've still got another 2 minutes to go. Okay, let's see who's done by now. If you can maybe say done in the chat, please. Don't want to rush you. Okay. Okay, so there's 7 people who've said done. Is that all 3? You've done A and B and C? Okay, that's fine, Zonaka. So post something over there. I'll wait a little bit longer. Okay. Barbara, Ria, Marsha, Ayanda. Okay, so I'm going to wait 1 more minute and then we're going to go through some answers. Okay, all right, so Chrissy, Oratile, Ayanda, all right, let's go through this. Okay, so for the first one, A, who would like to share their answer? I know there were a couple of answers in the chat, but the ratio of AG is to GF is what? Ria, go for it.
Good evening, ma'am.
Good evening.
Ma'am, I got the ratio for GF and AG is 2 to 3.
2 is to 3 is the correct answer. Okay, so 2 is to 3 is perfect. Well done, Ria. That's 100%. Okay. What we would need to do though is we would need to set it out in the correct way. All right. So we would have to have written here that AB, did you do this, Ria? Did you write AB over BC?
Oh, yes, ma'am. I just thought I should skip that part.
No, that's fine. I'm just being thorough here. We don't want to miss up, but your answer is perfectly correct. Absolutely. Equals AG over GF. And then you would have said proportionality, intercept theorem. And then which lines are parallel, Ria?
Ma'am, BG is parallel to CF.
good, well done. And then you would have concluded, let me just move this down a little bit, let's get that out the way. Then we would have concluded that, sorry, let me just get my pen back. Oh, there we go. And then we would have said that this was 2/3 is equal to AG over GF, and therefore AG to GF is 2:3. Okay, lovely. Well done, Ria. That's perfect. Okay, the next one, B. Who would like to do that one for us? EG over GA. Who would like to share their answer for that question? Anyone want to share? Yes, Katleho, go for it.
I
Just
have
one,
the answer.
Katleho, just 1 second, just 1 second. You can certainly do that. Yes, Raphael and Lutando. If you said AG is to GF and you wrote it as 3:2, then that would be wrong. Yes. Okay, because AG is the smaller part of the ratio and GF is the larger part of the ratio. So that would be incorrect. Okay. Katleho, go for it. What were you going to say?
So, ma'am, I just know that the ratio is going to be 4/1. But, ma'am, I don't
Okay.
know how I got it. I really
Okay.
don't know.
Okay, so Katleho, how we set our work out is obviously really important because you're going to get a mark for the answer. But if this question was, say, out of 3 marks, you would end up losing the other 2. Or if it was out of 2 marks, you'd end up losing a mark. And we don't want that to happen. Okay, so it is important that we set it out correctly. Okay, so EG over GA is, EG is this bit over here. And GA, let's just do that in a slightly different color, is going to be that bit over there. All right, so we're working along the same straight line. There's not an awful lot of working that we would need to show here, but what we would have to include in this answer, all right, is the length of FE. Did you state the length of FE? Katleho, did you write down what FE was equal to?
5x, ma'am.
Okay, absolutely. Katleho, did you say that? Did you say that FE was equal to 5?
No, ma'am. Somebody did that before me.
Okay, that's fine. Okay, so that's where you would have lost a mark. Remember, they gave us AF equals FE. Okay, so they gave us AF equals FE. That was given to us. So therefore, FE would also be equal to 5 in this case, just like AF would be. So therefore, EG over GA is going to be equal to 5 plus 3 is 8 over 2, and that's where you got 4 or 4/1 from. Okay. All right. Anybody want to share how they did C with us, please? How did you do C?
Equals 8 over.
Mitchell, do you want to say that to us?
Ma'am, I have a quick question.
Okay, Ludwina, go for it.
Ma'am, the length of FE, is that 5 in terms of centimeters or ratios? I mean, proportionality.
In terms of proportionality. Okay, remember we don't know the length of AG, GF, and FE. Okay, so on this side over here, we know that that was centimeters and we know that that was centimeters, but we don't know the lengths of the sides on the other side. So that's just the ratio. Okay.
Thank you, ma'am.
All right, no problem. Ria, I see you've got a question, or unless you want to share your answer for C with us, Ria?
Ma'am, I want to share my answer for C. But
Beautiful, go for
the
it.
thing is, with C, right?
Mm-hmm.
I noticed that AB plus BC equals 5, and CD plus
Just hang on to say that
DE
again.
equals...
You noticed that, sorry, just hang on. You noticed that AB plus BC equals 5, and you noticed that?
And I noticed that CD plus DE was also 5. And
Okay.
I said that the side AC equals the side CE because they're both 5, but I don't know if that's correct because like I got FE. Yeah, I got.
Okay.
Yeah, I got. Yeah. And
All
then I
right,
said AC equals to CE.
Okay, all right. Now, unfortunately, Ria, that isn't correct. In this particular question, it just happens to work out that the sum of AB and BC happens to be the same as the sum of CD and DE. But that's not going to actually help us in this situation because they want us to prove that these DG is parallel to CA using the converse of the proportionality intercept theorem. So what I find useful in a situation like this is to approach the question as follows, okay? Go and highlight the lines or draw arrows on the lines that they want you to prove are parallel. So that's this one over here and this one over here. Okay, then what you're going to do is you're going to draw a triangle around those lines. Remember, this line here, GD, is functioning as the line parallel to the third side of the triangle. Okay, so you are correct in, I suppose, in the triangle that you're working in, you're just not looking at the right sides because line GD cuts the remaining two sides into the same proportion. The one is EC, but the other one is actually EA. So you're supposed to be working with EC and EA. Does that make sense to you? Ria?
Yes, ma'am. That makes a lot of sense. I didn't notice that.
Okay,
I didn't
all
see.
right.
I didn't see
So
that.
when
Thank you, ma'am.
that's fine. So remember the proportionate. Well, this we're doing the converse, obviously, but proportionality intercept theorem tells us, all right, if one line is parallel to the third side of the triangle, it cuts the remaining two sides into the same proportions. So the two sides that have been, well, we've got to show that they're cut into the same proportions has to be those two over there like that. Okay, now Palesa, go for it. Palesa?
Afternoon, ma'am.
Afternoon.
Okay, so this is how I did it. I said EG over GA.
Just hang on a second. Okay, that's fine. Okay, so EG over GA. Keep going. Lovely.
It's equals to 8 over 2 because I added the 5 and the 3.
Sure.
And then I said underneath ED over CE is equals to 4 over 1. So
Lovely.
automatically EG over GA is equals to 4 over 1 also. Yeah, that's how I did it. And then I wrote converse of the proportionality theorem.
Okay, now after you've concluded EG over GA equals ED over CD, just before you write converse proportionality theorem, just write down what they're asking you to prove, okay? Because this proportion here proves that GD is parallel to AC. So we just want to conclude our argument in the correct way. So what did I say? GD parallel to AC, that's it. And then next to that, what did you write, Palesa?
I forgot to write the reasons.
That's okay. All right. So next to this, you have to write converse proportionality intercept theorem. Okay, now realistically, okay, Pinga, I'm going to answer your question now. I just wanted to tell you guys where the marks for this would be allocated. Because we've already calculated this first bit in the previous question, they wouldn't give us marks for that again. So I imagine that they would give us a mark for getting 4 over 1, and then there would be 1 mark for our statement and 1 mark for our reason. Okay, well, it would be 1 mark for both. They're not going to give us a mark for the parallel lines because that's what they wanted us to prove. But this statement over here is what proves those lines are parallel. So those two together would be worth 1 mark. Okay, now Pinga, let me just see what you're saying. Ma'am, can we do, let's just see, let me just go up here, Pinga. Can we do CD over CE. Yes, absolutely. So there's so many variations that you can actually make here, Penga. We're just working with the most obvious one, also because we worked out in the previous question what EG over GA was. But yes, if you wanted to do CD over CE, then you could work with AG over AE. Or you could work with GE over AE, and then you'd have to work with DE over CE. So there's many different combinations that we could make. Yeah. All right. So nothing wrong with any of those as well. Any other questions, anybody? Any other questions? How are we feeling about converse proportionality intercept theorem? Oh, Zwanaka, my apologies. I didn't see your hand up. Zwanaka, do you want to ask a question?
Ma'am, for B, I'd like to ask, how exactly did you get number 5 for FE?
Okay, so Zwanaka, up here in the information for the question, do you see here it tells us that AF and FE are equal? I'm just busy highlighting it in purple at the moment. Can you see that?
Oh,
okay. So that's where it comes from. Once I
okay.
knew that the ratio of AG to GF was 2:3, I knew that the proportion of AF would be 5, and then FE would also be 5. Does that make sense?
Yes, ma'am.
Okay, all right, no problem. Okay. Tando, you're saying you're understanding both concepts since you went, okay, well, that's really good. Okay. No, they're only ratios, Eric. Those are not real lengths. I don't know if you remember, somebody else did ask that. I think it was Lidwina asked that question earlier. So yeah, those are just ratios. Okay, so
Ma'am?
yes, sorry, I don't know who's talking to me.
It's Lidwina, ma'am. A
Oh,
quick
sorry,
question
Lidwina.
to add on to Eric's question.
Yeah.
So basically, basically, to be able to tell the difference as to when we should give ratios or lengths, will they specify in the question give the length for this, for say per se AB?
Yes, they can do. So I mean, if you sort of go back to what we were doing over here they asked us to find the length. When they said find RS correct to the nearest whole number, they didn't want a ratio, they wanted the length of RS. That's why we had our answer in millimeters or whatever the case was. Where just find a different question. No, they weren't asking us for that. That was the converse. Okay, so yes, you will be able to tell from the question whether they want a ratio or whether they actually want the length.
Okay,
All right.
thank you.
So yeah, so if they want the ratio, they'll ask it in a sense like they did with question A here, where they say AG is to GF, or like Eric had mentioned earlier, they can also ask that in a fraction. So EG over GA means they're looking for a ratio. If they said to us determine AG, then they want the length of AG. Okay, I think it's time for the poll, unless there are any other last questions. There we go. Please answer the poll before you go, guys. Sure, Penga. Okay, that's your homework.